Hi, boys and girls. Now we're going to spend some time talking about Newton's third law. This law is the one that I mentioned in the last video about action and reaction. For every action, there's an equal and opposite reaction. Now, in a silly way, I could say if I did the terrible, horrible action of just like come up and smacking someone, then they would react back at me. But in science, it's really is kind of that way. Everything that you do has a reaction. Sometimes it's not very noticeable. For instance, if I am just pushing on my desk, right? You don't really feel like there's any kind of reaction happening back to me. But what I would say to you is that there is force pushing back on my hand. And if you try this, like you're literally going to kind of feel it, right? If harder you push, the more it feels like the desk is pushing back at you. So for every action, there's an equal and opposite reaction. One way that, and this is kind of obvious, is like the kickback. If someone was shooting a gun, the if you were ever trying to learn how to do that, which I'm not a big fan of it, so don't get too mad at me, but you can actually get really hurt if you're shooting a rifle because the force that's used to push the bullet forward also has equal reaction back at your shoulder. So someone who doesn't know what they're doing can hurt themselves very badly while trying to shoot a gun. All right, so every action has an equal and opposite reaction. Let's watch the study jam together.
Ow.
Zoe, watch out!
Ouch!
Hey, are you okay?
Yeah. Oh, hard bench. Guess I wasn't looking.
Now that's what I call action and reaction.
Action and what?
Action and reaction. It's Newton's third law of motion.
What?
You know Isaac Newton, the gravity guy? He realized that for every action, there is an equal and opposite reaction.
Like, if I run into you, you run into me at the same time?
Pretty much, but there's more to it. Okay, so when you bumped into me, you applied force or pressure against me.
Yeah, sorry about that.
According to Newton's law, my body pressed back against you with the same force.
Come on.
We both felt the same force because the forces from our bodies pressed in opposite directions.
Yeah, but if we hit with the same force, how come only I got knocked down?
Good question.
All right, let's ask that. Why do you think that she was the one that got knocked down rather than him? Do you think the forces actually were equal when they ran into each other? And if not, looking at the two of them, let's just go back a tiny little bit. Right about here. A little bit more. All right, I can't get to where was it? Right where you could see it. All right, right? It seems to me like he's a lot bigger and heavier than her. So perhaps because he had more mass, he also had more inertia, which meant that his body wanted to keep doing what it's doing more than her body. So when you had the extra mass coming at her, she was the one that got knocked out of the way. Right? I bet you were thinking the same thing. Let's see what they say.
Good question, champ. It's all a question of mass. How much matter is in something?
Now look at that. I'm a genius. Okay.
First of all, who has greater mass, you or me?
Is that a trick question? You, obviously.
Well, according to Newton, when two objects with different mass collide, they'll accelerate at different rates.
Accelerate?
Change their speed and direction.
So, even though their forces are the same, one will accelerate more than the other?
You got it. The object with smaller mass will accelerate more.
Smaller? That would be me. So I fell, and you didn't.
Hey.
Now look at this idea, guys. All right. He was running with, and even though he had more mass and was able to knock her out, he had less acceleration, most likely because he had greater mass. Whereas she was like zipping along, but didn't have as much mass to knock him out of the way. It's really cool to think about.
Come to think of it, the same thing happened with you and my soccer ball. You hit each other with the same force, but the soccer ball went flying.
I got it now.
Oh, because she has more mass than the soccer ball. When they hit each other, she had more mass, so she's the one that changed the direction of the soccer ball, just like he changed the direction of her because she's less massive than him. Oh,
Because my mass was bigger, the ball accelerated more. How about when a baseball bat hits a ball?
Yep, both objects hit each other with equal force.
okay, but now, right, let's think this through before they start to tell it to you. So if the baseball bat hits the ball and they're both coming at each other with force that's probably equal, but we already know, and especially my baseball players, Gabe, Christian, although y'all play baseball, right? So when the ball hits the bat, we know it goes the other way, right? So I'm guessing the bat is more massive than the ball, right? All right. Otherwise, the bat would go flying. Now, remember last week in one of the videos, I told you about how if you hit a baseball bat into a bowling ball, it wouldn't move the bowling ball because the bowling ball is more massive, right? Instead, you probably would just crush your bat, right? Because the force of the bowling ball, because it has extra mass, would be more intense when it hits the less massive baseball bat and would just break it. All right. So this is kind of the opposite of that. The baseball has less mass, so it's the one that would be knocked further out of the way when it has a reaction.
In different directions. The ball goes flying because its mass is smaller. The way the bat is moving when it hits can make the ball go in different directions.
And what happens when two things that are the same mass collide? Like two pool balls.
Well, what do you think?
All right, so what if they have the exact same mass, like two pool balls, and they hit each other? Well, I know I've seen people play pool before, and when I've seen people play pool, I know the ball will go and hit each other. So I don't know, I guess it's about mass. They should go, though, in equal directions the opposite way if they hit exactly right. But if they don't hit exactly in the middle, then they'll still go in different directions. They'll just do it in wacky ways, right? So if they hit dead on middle, boing, and they're the same mass, they should go boing back out. Now, boys and girls, in my classroom, do we still have a Newton's cradle? We do, right? Unless it's broken. I can't remember if we have one right now. But you know the little thing with the balls that goes boing, and then everything goes the other way, right? Yeah, Newton's cradle is perfect for Newton's third law. So I'll see if I can find one online to show you in just a little bit.
Well, they hit each other with the same force, and the forces press in different directions, so they have the same acceleration?
Yeah.
Wow, this action and reaction thing is a little complicated, but I think I've got it. Newton's third law says that for every action, there's an equal and opposite reaction. That means that when two things collide, they press with the same force in opposite direction.
But remember, if they don't press with the same force, then that means you have unbalanced forces, and that's what causes objects to accelerate/move.
That's why you and I both felt it when we bumped into each other. And when the objects have different mass, like we do, they'll also have different acceleration. The object with smaller mass, in this case me, will speed up or accelerate more.
And she scores. Now that's what I call a smart reaction.
What can I say? I'm just a genius in full force.
Oh, gosh. Oh, those jokes kill me. All right, I'll see you in a little bit. Good job.